So hello, welcome back. Let's talk about pixels today. And I'm not talking about the movie, but I'm talking about input pixels into a sensor and output pixels. With the new release of some of the high pixel cameras, there's a lot of discussions about, do we need 61 megapixels, do we need 42 megapixels, where does it end, where does it start, and I think there's a lot of confusion there, and I just wanted to give you my view on what I think is happening and why we need to start moving away from thinking about pixels as one pixel on the sensor side is one pixel on my picture, because I think that time is sort of going away really quickly. Because it's basically is a way of thinking which I've made a video before about. We should throw away the name RAW files, and people took it like, well, Sony should only support JPEG, which I got a lot of flack for. But the idea here is that it just does not define anymore what is going to happen with the next generation of sensors, and I want to explain it a little bit more. So yeah, let's look at some information that we already know and then look at it in detail. Now, in detail means that does not mean that what I'm going to say is technically correct. I'm just trying to make a point, and some of the examples I will show, because there's a lot of data, is probably way off, doesn't make any sense, but it does show you a little bit, I think, about what Sony is thinking and what other brands are thinking about what is going to happen with sensors. And we should not forget that a sensor is basically nothing else than trying to capture an analog signal as best as we can, and any trick is allowed to get these pixels into a form that we want to use. And the form that we want to use is not always the same. If we are talking about, let's say, a 4K video signal and we want to have 60 frames a second, that's totally a different use case than we want to use a 61 megapixel sensor to get the best detail, maybe with even using 10 shots or 16 shots in pixel shift mode or whatever. Totally different use case. So what I think we will see is that we are going to see more flexible sensors, right? So sensors that can change itself and its behavior to output different types of signals in a more flexible way to fit the use case. I know this sounds a little bit cryptic, but I will when we look at this document, we will see what I mean. And I think that's where we are going. So the argument that we're now seeing is basically Sony, we don't need these much megapixels, that doesn't make any sense, because I don't have enough hard disk space, or the rest of the camera can't handle the load, etc, etc. Well, in reality we will probably see that these cameras will be put in certain modes in certain times, and that will determine the amount of data coming up out of this sensor and the amount of work that still needs to be done with the next modules in the camera, if that makes sense. The second thing that we are seeing is that, well, Sony, if they do this 61 megapixel sensor, they should at least support RAW modes, which are 24 megapixels or 42 or whatever size they want, which I agree with, but normally that would have happened, so in the old Canon and Nikon, it would have happened basically further along in the chain. Which doesn't really help a lot. So if you're looking at the camera again, it doesn't help you a lot with sort of the first part of the sensor, right? That means only before you start saving it, you kind of scale it down to make sure that it's easier for you to handle in your workflow. But the tricks that we are going to look at a little bit today are totally of a different ballpark, because they really are about getting different behaviors from the sensor. So let's look into this a little bit, and my only goal, really my only goal, is to maybe go out yourself, look at some of the documentation, think about what you are seeing and what the numbers are telling you, and then sort of come to the same conclusion that I am sort of coming, that the next step is not really talking about the amount of pixels on the sensor anymore, but basically the amount of pixels coming out of a sensor before it goes to either a normal chip or into a stack design sort of chip, and what will happen then. So let me turn everything to this picture, and then I can also pick up my laptop and show you a little bit what I'm talking about. So this is documentation of a new sensor that Sony has developed, and that might be part of the new lineup of cameras. And I think the first one we might see this is actually, if I look at them, I can imagine it can be used something like this, both in the A9 and in the A7S III, or maybe even a camera in between, but these tricks are kind of generic. So, and again, my only point to make is that there's a difference between the pixels which it uses to capture the data to the output pixels. So what we are seeing here is something called a quad BIOS director. So basically what that means that, so let me also scroll to the model number so that you can search for it yourself. So this is a Sony product, is a sensor called the 521 CQR, and it's a full frame sensor, and it's basically cryptically being sort of described as a low pixel count sensor, right? So it basically tells you, well, let me zoom in a little bit in the description, because in the description itself it's already quite sort of telling, right? So, and I'm not saying that this one will be used in any cameras of Sony. That's not my point. But let's look a little bit at what it tells us. So it's a 42 millimeter sensor. Blah blah blah. That's not important. Okay. With a color square pixel array and an effective 15.36 megapixels. So that kind of hints to this might be something for the S3, right? 12-bit digital output makes it possible to read out signals of 15.36 megapixel effective sensors at a speed of 60 frames a second. Okay, that sounds like a reasonable video feature, right? In addition, the quad BIOS output makes it possible to read out of signals of 61.44 megapixels. That's already a very interesting number, because that's the same number that we heard before when we were talking about the A7R4, right? Which is 61 megapixels. Just keep that in mind. So furthermore, it realizes 12-bit output for shooting high-speed moving pictures by horizontal and vertical addition. So basically what they are saying is we can sort of use all these, let's say, base pixels of 61 megapixels, which we will show later, and fiddle with them, throw stuff away, add them, average them, do different things in timing, have them fill up at different speeds to get different results, right? So the input pixels does not really relate anymore to the output pixels of the sensor. So realizing high sensitivity, low dark current, this sensor also has an electronic shutter function with variable storage time. So think about that. So with variable storage time. So that means normally, let me put myself a bit back in the picture. So normally, let's say a bucket, because that's basically what's happening. You have a pixel, let's say a bucket, that fills up. And once it is full, well, you can't go any further anymore, and basically you are stuck in full white, or whatever color this thingy is, right? So RGB. So what they are saying, well, maybe we can start playing out with how fast they can fill. Right, that's basically what they are saying here. So that makes sense, because if you are in a low light situation, you want to fill, or in high light situation, you want to have more capacity than in a low one. So again, playing with what can be done inside these pixels. So let's okay. In addition, this product is designed for use in commercial use digital stills cameras and consumer using camcorders. When using this in addition application, no, that's just that you need to call them if you want to use it in a different way. Again, you can read all this, and some of these things might make sense to you. They might make sense to me. Sometimes they do, sometimes they don't, but that's not important, because that's not the point I want to make. The point I want to make is basically starting here, right? So here you see basically the structure, what they are doing. So what they are saying, well, we have a 15 megapixel output sensor, that's what they're kind of claiming, but we can group them into different groups of 4. And the idea is that in different modes that you can use it, that all these 4 pixels can be read out, so the value of it can be read out in one go. So basically you don't have one sort of bucket filling up, but you have 4 of them filling up, but they have made it the way that they can read them at the same speed, right? So I hope this makes sense. Now, it becomes quite interesting, because now they say, okay, there's also an HDR function available by dividing exposure time in the 4 same color pixels into a long exposure and a short exposure pixel. So that means that all these buckets are not filling up at the same speed, which gives you this trick. Now then they throw out 2 terms called LGC pixels and ACG pixels. Now if you search for them, you will find some research and some white paper stuff, which I will also put in the description, where that's being explained basically what kind of tricks they can do with this, let's say, not taking just one pixel, but taking multiple pixels and throwing them together in different modes, right? And again, this is by a company called Alptina, which I always figured was now taken over by Sony, but maybe they only took over their sensor fabs and some of their patents. Is now owned by another company, but even then, that's here they describe some of the tricks that they are doing, and I'm pretty sure that Sony is referencing these kind of technologies. So going back, because sorry for the long introduction, going back, this sounds like this is only a 15 megapixel sensor, but now, so this becomes very interesting. So when normal operation for same pixel, when normal operation for same pixel, I can't read it anymore, sorry. When normal operation, 4 same color pixels are added and made 1 pixel. So basically what I was just talking about. And the output of the Bayer array, blah, blah. So they mean that they don't lose any time. So basically they build in the hardware that it doesn't take any extra time. So this 61 megapixel sensor, because that's what it is able to be read out at the normal speed they would be able to do as a 15 megapixel sensor, right? That's not a detail, that's quite an important sort of thing. So, and then it becomes a little bit cryptic. In addition, a group of divided 4 same pixels is defined as 1 pixel unit in this product specification. That kind of makes you think that you can only read out 1 megapixels, right? And also that's what you are seeing here. They are basically talking about the 4 modes that it would normally be used at, right? So they talk about the effective pixels, they talked about the active pixels, so I'm guessing there's also some face detection pixels there possibly, or some room for that, or some other things that I don't understand. But at least it's clear that they kind of push this 15 megapixel sort of part. But then if you look at the readout modes, and why would you put them in the specifications if you can't use them, right? So clearly you can read out this sensor in different modes. Now look at these modes, right? So let's first look at some of them which kind of pop out simply because of their refresh rate, right? So you can see one like 60 Hertz, which clearly hints to video. This one, 29.97. Okay, so that's 12 megapixels. That's kind of the old resolution of the A7S III, right? At 30 frames a second at 14 bits. Okay, that's kind of cool. But then look at totally different modes. 7A was, I think, interesting. Is it interesting? Let me see. So this is the maximum frame rate and the depth, right? So you see here 61 megapixels, so that's basically the A7R3 sort of resolution at only 2 frames a second, but at 16-bit, right? But the one below it, 7B, is already much more interesting, right? You see the same resolution, 61.17 megapixels of the A7R3, but at a frame rate of 6 frames a second at 14 bits, right? So clearly this sensor can be used as a high as a high pixel count sensor, right? The same with sort of high bit rates. So if you're looking at 4K sort of video, you see here one which says 60 Hertz, right? So let me see if it makes sense. This kind of doesn't make sense in a way because, well, unless you sort of consider a little bit of upscaling here, because the width does not really fit, the height does not really hit the 2K border, but I'm pretty sure there was another one which did. So these two, for example, 92. So these are clearly 8 megapixels, 8 megapixels, 8 megapixels, and you can see the speed, right? So 12C, for example, 92 frames a second at 12 bits. Okay, that's 4K is kind of interesting, right? I can also imagine that some of the higher ones, like this one, 9C, right? So it talks about 12 megapixels, so that basically means that it has to do with of the way. Of course, you most likely want to have 16:9 video. So this is probably an interesting one. But again, I don't want to go to the whole list, but the fact that they give you a list of roughly 55 different, well, that's not how they define it, but there are many modes, clearly, that you can sort of drive this sensor and get stuff out of the sensor. So there is no direct relationship anymore between the input and the output of the sensor. And that's the kind of the point I want to make, because clearly this sensor can be used, let me put this away. So clearly this sensor can be used to create cameras and to create sensors which have a totally different way of gathering the data than already behind the sensor. And that's a tricky answer, sorry to be a bit tricky about this, because that could be a stack sensor already as part of that, or going to the first processor that's in there to bring it down to a certain number that it can handle, right? So that's done on chip, and that's kind of amazing, because these are, as far as we know, well, we know because they're talking about customers, that these are the ones that they are willing to sell. So it could be with their own stack designed that they sort of use these tricks and already in their own sensors go much further, because they can do it much closer to the place of the sensor before it goes to another place. So if you watch my previous video when I was talking about, I'm hoping that there will be an A9 Mark II, which is a higher pixel count. If you look, I'm not saying they are going to use this sensor, but if you look at the S3 or the S4, whatever it will be, or you look at a possible A9 Mark II, and you think about the tricks that they are showing you here, then clearly they can use this higher pixel count to bring it down to, let's say, 24 megapixels. Let's just do a thought experiment. Let's say they use a sensor like this in an A9, and they put it in 61 megapixel mode, and theoretically that's way too much to do what the A9 is doing, right? But it is totally thinkable that they will bring it down to 24 megapixels, right? So they scale this massive 61 megapixels using the tricks that we have just seen down to, let's say, 18, 24 megapixels, right? Let's assume 24, that's a good number. But they could do the same thing in crop mode. So you could basically have the same amount of pixels in crop mode that you could have in full frame mode. Now, maybe my numbers are off, or maybe, right, I'm not trying to be very precise here, sorry. But I want to make the point that downscaling, bringing the pixels on chips already together, using different pixels or buckets that they are filling up to basically get an end result out of the sensor before it goes into the rest of the camera is, I think, the mistake that many people are making when they are talking about, oh, this is a 61 megapixel sensor. That doesn't make any sense to me. It doesn't make any sense in the future. Because clearly it does make sense if you start thinking about it in a different way. I think Sony is not being that handy about this, for example, by not talking about this or not even adding old-fashioned raw, lower quality raw files. Right? I think for the A7R4, to me at least, it would already be a much more interesting camera if it would also allow me to scale back the 61 megapixels back to 42 again, or even 24. Because then, for me, it would mean that I could use an A7R4 basically in 24 megapixel mode, which is definitely then oversampling, which is sort of getting a better result because you have more green, red and blue pixels which are sort of combined into a 24 megapixel sort of shooting mode. A high frame rate because the data is not too much coming out of the sensor. High frame rate, A9 type of behavior. Well, if you put it in crop mode, just to get the extra reach, it will still be 24 megapixels, or in this case 26 megapixels. Have the same output to the rest of the camera, if that makes sense. So there's no downside for the rest of the system. So in doing the calculations, in doing the JPEG generation, in filling up the buffer, and in writing it to the cards, it would all be the same, because the sensor is basically already doing this pre-processing for us. So yeah, that's what I wanted to talk about a little bit in this video. Hopefully you agree, or at least you see what I'm trying to talk about here, because I really think that this is where Sony is going with their sensor designs, and that it will be much more difficult or even useless to look at the amount of pixels on a sensor compared to the amount of pixels being transported through the whole system. I hope this makes sense. And weirdly enough, let me end with that, nobody has an issue with this when we are talking about video, right? It's a totally accepted sort of story that most of the Sony cameras, the 24 megapixel cameras, are doing downscaling from 6K video to 4K video. And everybody agrees that this does not, oh, now we are getting way more data. Well, we are complaining that the bitrate is too low, but we are, and the bit depth is too low, but we are not really talking about the downscaling from 6K to 4K. We are totally fine with it. We even know that it has advantages. So it's kind of weird that we don't talk about it in that manner. That, oh, we don't want to have 24 megapixels video because that's too much data. Because we totally accept that this is handled in camera and made of good use by the engineers to create this output flow of pixels that we actually want to use. So yeah, thank you for watching, and see you in the next one. Bye bye.